Right, greetings, grade 12. So we're going to look now at functions. Grade 12 functions, we're going to be looking at inverses. So by the end of this lesson, you should be able to first recall and apply the principles learned in grade 10 and 11 to solve functions or problems related to functions. And also number 2, you should also be able to show an understanding of an inverse function and also be able to represent this on a graph, right? So you should be able to sketch the graphs of the function and its inverse on a Cartesian plane. Okay, moving on. Right, so grade 11 revision, you are supposed to know, right, the functions. So here we've got the functions, right? We've got the linear function there and the equation, and it's a straight line graph. And we've got the parabola, we've got the completed square format of the equation, we've got the standard format of the equation, and it gives you a parabola. And we've got a hyperbola, the equation of a hyperbola there, and a graph there of a hyperbola, or we can call that the reciprocal function. So hyperbola is the graph and reciprocal function is the equation. And then we've got the exponential function, which is there is the equation, and that is the graph. So these are the 4 functions that you need to know. Of course, we will look later on in another lesson. We will have to look at the trig functions. But for now, these are the functions that you need to know, 4 of them. Moving on. So there we are. These are the parameters. So in terms of these parameters, right, so you need to know the effects of the parameters, A parameter, the P parameter, and the Q parameter. What effects do those parameters have? So you will see that these parameters, their effects are the same throughout all the functions altogether. If you look at the A, it affects it affects the shape of the graph. That is the gradient of the graph. How steep the graph is, how wide the graph is, that is affected by the A parameter. And then the Q parameter, this affects the graph by shifting it horizontally altogether. Whether if you increase it, the graph shifts upwards, so it affects the vertical shift of the graph. And then we've got the P parameter. This affects the horizontal shift of the graph. So these are general throughout the all these functions altogether. Once you know the effect of one parameter on a certain function, the effect is the same throughout. Okay, so this is all revision of grade 10 and 11 stuff. Now let's look at what a function is. Let's just look at what you learned about what a function is. So remember, a function is a relation, right, between 2 variables, right? So it's a relationship, a special relation where we can say that number 1, for every value of x, there is at least or at most 1, which means it has to be either a 1-to-1 or a many-to-1. So the one domain parameter or element should be related to at most 1. The moment it becomes more, then you know that it's not a function. So for every value of x, there is at most 1 y value altogether, right? Each element of the domain is associated with only one element of the range. So you are given a set of values: x value 1, y value 2, x value 2, y value 4, x value 3, y value 6. That is a function. It's a 1-to-1. So in the second one there, you see that it's a many-to-1 and it's not a function. So functions will have a mapping of 1 to 1 or many to 1. The moment it becomes 1 to many, it's not a function. So 1 to 1, a function, many to 1, a function, 1 to many, not a function. So you can see here, the first parabola there, it's a function because it's a 1 to many. What do we mean when we say 1 to many? Right, so it's a many to 1, one many to 1. So we can say that if we've got a y value there, you see that it will have two x values, a negative one and a positive one. So that one is a many to 1, many domain elements mapping to one range element. And this one is not a function because it's a many to many. So you see that if we've got x values there, these can be mapped to a y value and another y value up there. Can you see that? So this one again, it's a many to many, it's not a function. Same with the third one. Moving on. Right? A function has 1 to 1 or 1 many to 1. So it has to be a 1 to 1. Mind my handwriting there. So it's a 1 to 1 or a many to 1 function. So a function is a 1 to 1 or a many to 1. So let's have some examples here. So let's do these ones. All right, let's quickly do this. All right, might take a little while because I have to draw these things for you. There we go. Right. Right. So there we go. There we go. Right. Now let's look at this. Right. Now you can see here. This is the domain, which means the x values. These are the x values, the domain, range, domain, range, domain, range, domain, and range. Excuse me for that. Right, let's proceed. Now let's do some mapping and see. If we've got one which is like that, right, let's say we've got those mappings. There we go. Right, the first one there is a 1-to-1 mapping, so it's a function. The second one there, it's a many to 1 mapping. It's a function. The third one there, it's a 1-to-many mapping. It's not a function. And the fourth one there, it's a many to many mapping. It's not a function. So only 1-to-1 and many to 1 is a function. Please try to remember that. Okay, let's move on. Now let's look at inverse functions. Right. The inverse of 1-to-1 functions. That is what we are going to look at first. So we have to know the inverse operations. The inverse operation of addition is to subtract. The inverse operation of subtracting is addition. And the inverse of multiplying is to divide. The inverse of dividing is to multiply. The inverse of a square is a square root. The inverse of a square root is a square. The inverse of a cube is a cube root. The inverse of a cube root is a cube, and so forth and so forth. Are we together? Now let's look at the steps for finding the inverse of a function. Right? There are 2 steps. Step number 1, you swap the positions of x and y. Where there was y, you put x. Where there was x, you put y. And then step number 2, you solve for y, or make y subject of the formula. Right, let's look at an example. This is a very easy task. An example, let's say you are given, find the inverse of y is equals to, or f of x is equals to 2x plus 5 all over 3. So you can let where there's f of x is the same as y, and then you swap the positions. Where there's x you put y, where there's y you put x, and then you make y subject of the formula. That is now algebraic, your algebraic manipulation, your skills of algebra, right? You solve for y. Solving for y, you can see first multiply both sides by 3, because the inverse of division is multiplication, inverse of subtraction is addition. So your inverse function becomes y is equals to 3x minus 5 all over 2. What kind of an equation is that? That one is a linear equation. Let's look at another example. This time we want to do the example with a graph. Right, using a graph now, well, first of all, let's use the calculations to find the inverse of a function. Y is equals to 2x plus 8. So remember, we swap the positions. Where there is x, we put y, and then we solve for y. In this case, it's going to be y will be equals to x all over 2 minus 4. Y is equals to x all over 2 minus 4. That becomes your inverse function. Now, let's go and draw some graphs. Let's represent this graphically. So, graphically, right, there we go. So, let's draw that graph. So, here we go, our Cartesian plane. Here is our Cartesian plane, and then our graph y is equals to 2x plus 8 is the graph in the inverse. Let's put it in blue. Y is equals to x, right? And then let's draw it graphically. So if you look, there we go. If you look at these two graphs, you see that they have something in common, right? You see that, remember, for the inverse function, the range, the domain of the original function becomes the range, and the range becomes the domain. So we can say graphically it's like a reflection taking place, in reflection about the line y is equals to x. So when we talk about reflection, it's basically meaning, if we look at this 8 and this one, you can see that those points are being reflected, right? Which means the distance of the coordinates of these two are equidistant from the line y is equals to x. So y is equals to x becomes the mirror between the inverse functions. Are we together? Moving on, let's do another example. They say the inverse now of a many to one. So with the 1 to 1, there were no restrictions, no problems whatsoever. But let's look at the inverse of a many to 1. So it will pose a problem, because remember, a function is a special relation where we have a many to 1, 1 to 1, or a many to 1. The moment it becomes otherwise, it's not a function. So if we look at this one, we can see we end up with an inverse, right? Y is equals to square root of x all over 2. If we are to move on, there are certain conditions that we want to look at here. So they say, is it a function? So you see that that one is not a function at all, right? So remember, let's look. Let's use the domain and the range. So we substitute the values of the domain into our function. We say if x is equals to 4, what is y? Y will give us two values, -1 and a +1. If we say x is equals to 9, what is y? Y will be -3 and a +3. So we can see that this kind of a function, can you see, it's giving us two values. For every single value of the domain, we're having two values of the range. So this results in a one-to-many mapping, Hence, y is equals to plus or minus square root of x all over 2 is not a function. So how do we make this a function? Questions you can be asking. What do we do to make the inverse of a many to 1 a function? Question. The answer is we introduce a restriction, right? We introduce a restriction to the function before we find the inverse. Okay, so why do we do this? Question. So we do this so that this is done because the domain of the function becomes the range, and also the range of the function becomes the domain of the inverse. So which means if it was a many to 1, which means the inverse becomes a 1 to many. So which means the moment we have a many to 1 mapping or a relation of a function, so the inverse automatically is not going to be a function. So we put a restriction on the original function so that it moves from being a many to 1 relation and becomes a 1 to 1. So let's go back to our example and put a restriction. So which means now when it is a many to 1, remember for a 1 to 1 we only 2 steps. So for finding inverse of a many to 1, now we have 3 steps. The first one which we add to it is putting a restriction. So let's go back to example. Find inverse of y is equals to 4x squared. Now it has to be a function. So step number 1, for domain of the function y is equals to 4x squared, we introduce a restriction either x is greater than 0 or x is less than 0, where x is an element of a real number. So you have to specify that restriction, right? Now step number 2, now you follow the rest of the steps of finding the inverse. You interchange the positions of x and y, then you solve for y, right? So your inverse now will move with the restriction. Remember, the restriction on the original function was for the domain, and now the restriction now in the inverse becomes a restriction on your range values. So it becomes a 1-to-1 relation, which means it becomes a function. So can you see the restriction which I carried forward with, or which I used in this case? I used this restriction for the domain, and this results in me becoming the restriction for the range for the inverse function. Can you see that? Let's draw this on a graph. On a graph again, let's draw the Cartesian plane. Right, there is our Cartesian plane. Then we draw the graphs. Remember, there's only one arm of the parabola we will be having, one arm, and then remember it's a reflection about the line y is equals to x, that is our mirror. There we go. So you can see we use only one arm of the parabola, because if we had used 2, for example, if we had used 2 like that, that would be a function, and then for the inverse now it was going to come like that. Sorry, it would come like that, and this now will not be a function because it becomes a 1-to-many relation. Are we together? So basically we put the restriction. The restriction will allow us only to use one arm of the parabola. Moving on. So what can we conclude? What is our conclusion? Right? We can conclude that with inverse functions, inverse function of 1-to-1, you just do the 2 steps and use the knowledge of the shape of the graph and the dual intercept methods that you find the x-intercept, the y-intercept, and you can draw the graph. Examples of 1-to-1 functions include the linear function, exponential function, and the hyperbolic function. And for the inverse of a many to 1, for it to be a function, you need to introduce a restriction right? So that the inverse has to become a function. So example of a many to one function is a parabola or a quadratic function. You have to introduce a restriction so that its inverse becomes a function. I hope this has been helpful, grade 12s. Right, great stuff. So you can now attempt questions. If you've got any questions, you can WhatsApp me on my number. You have them, right? Or on Edmodo. Then we can discuss. Okay. Enjoy the rest of the lesson, right? Following, you find some worksheets for you to do. Thank you. Enjoy the rest of your lesson.